Hi folks, let's return to our panel with the VFD that we used to present the ULN2804, and what we are going to do today is use a ULN2981 instead, thus adding another driver to our lists. It is important to remember that our ULN2804 controls the negative. This implies the permanent polarization of the grids and segments with the application of the plus 24 volts AC through the 47K resistor bars. By applying the ULN2981, we no longer need to use permanent polarization, as it controls the positive from the plus 5 volts DC to the maximum of the 50 volts DC. To obtain a voltage close of the plus 35 volts, I recommend using two DC-DC converters of the plus 24 volts and the plus 12 volts associated in series to obtain a satisfactory VFD brightness. Please do not forget that the primary and the secondary conductors of the converters must be isolated. This is essential for use in series or using the negative or positive as a reference for GND. What has said in the previous video applies to this one as well. We have to keep the pin MR of the Bose 74LS164 with a value high. It can be with a 2.2 case resistor connected to the plus 5 volts DC or with a pin controlled by the Arduino. In this case I use the pin 10. The clock also goes to the Bose LS164 simultaneously. The data on the first one is the pin A and B, and from the pin Q7 of the first one, the data goes to the pin A and B of the second one. The QX connect to the 2981 inputs, and we just need to remove the till from the bytes to be sent in the code. Replacing the ULN2981 is not straightforward. It requires some attention when changing the pin 10, which we had previously left free or not connected, and now has to be connected to the GND. Pin 9, which has previously a GND, now receives the plus 24 that previously went to the resistor bars. Resistors bars are no longer used with this IC, so we have to remove them. And that is all we need to do. Okay, we'll go disconnect the power and apply the modifications we need to do it. In this case, our GND of the pin 9 go to the pin 10 at both ICs. I do it at the second IC, pin 9 to the pin 10, and now the positive present in the resistors, in the bar of the resistors, go to the pin 9 in the both ICs also, okay? And remove the both resistors. This wire need to go to the place, and now is only replace the ICs. I use a needle to lift Okay. Place in position the new driver. We have applied all the modifications in the hardware, and now I do the reset at Arduino. And you will see the result of the code running with the till before the bytes to be sent. They are in the inverted mode. And this is our result after replace the ICs. The next step is apply a small VFD, only to you can see how it's easy to replace the VFD. As I refer, I connect another small VFD. I have done one video about how to proceed with the identification of the grids and segments. I believe you already see it. And also I need apply a resistor of 47 ohms in serial with the both diodes to protect the filament, because this is a small filament and 5 volts DC is too much to power up it. I use the 2 dots in the middle as a separator. In this case is the same to tell this is the segment H of the digits, and the 2 dots is present in the grid number 5, I think. By this reason I use 4 grids, 4 digits, and you can see I skip the seconds. Okay, this is the grid 0 and 1 is not connected, I skip it. And final, I like refer the importance of the filters in displays. Okay, here you can see the digits is not well defined, and when I apply the filter you see it's much better. The problem happened because the light of this digit here disturb the digit is outside, and so on. Okay, here you see digit 1 have a shadow. This shadow belongs to the dynamic representation and also from some lights coming from this digit, or the same digit itself. Okay, when I apply the filter I suppress this effect.